Hello everyone. Uh, Welcome to one more video on engineering economics. And again, in this video, I'm going to solve this particular problem 6.18 from the sixth chapter on cost analysis in the engineering economics topic. So the question is in front of you. You can just have a look at this, and you can try to understand the question. You can try to solve it. Meanwhile, I will also make the answer, and then you can compare your answer with my answer. Okay. So you can pause the video, go through the question once, understand it, and then we'll solve it. Okay. So let's start. The city of Carlsbad in California is considered building a 300 million water desalination plant. Okay, so what is this 300 million? That is the initial investment. Okay, so let me write down the given data. So the initial investment is $300 million. So I think I will solve this entire problem in the units of millions of dollars. Okay. The facility would be the largest in Western Hemisphere, producing 50 million gallons of drinking water a day. So what is the production? 50 million gallons per day. So immediately I can get the annual production. Annual production. Let's call it P. No, P is present value. Okay. I'll just say production. So 50 multiplied by 365. So how much that will be? So let me just quickly do that calculation. So 50 multiplied by 365. So I'm getting 18,250 million gallons per year. So this is the annual production. So far we use this data, enough to supply this one. I think it's not required. So anyway, the plant which uses improved membranes and pumping system to bring down the energy cost to $1.10 in electricity to produce 1,000 gallons of water. Okay, so what is my savings? Savings is $1.1. Okay, per 1,000 gallons produced. So if I produce 1,000 gallons, then I save 1.1. Then if I produce this many millions of gallons, then I can now calculate the annual savings actually. Okay, so what is my annual savings? So I just have to multiply. See, the annual production is known, 18,250 million gallons per year, and then savings is known, $1.1 per 1,000 gallons. So I just simply do the calculation like this. So 18,250 million. Okay, so multiplied by 1.1 and divided by 1,000. Okay, so this is my annual saving. So this is in dollars. So now I can simply do this calculation right away. So I have this 18,250 already. So divided by I'll go for 1,000 and multiplied by 1.1. So I'm getting $20.075. Okay, so let me just round it off to $20 million. Okay, $20 million per year. So this is my savings in terms of dollars. Okay, so we completed this one, we use this one, we use. Now, suppose the desalination plant is fully operational and you expect to operate it continuously for 20 years. So the life of the project is 20 years. With an estimated salvage value of $20 million. Okay, salvage value S is $20 million. The operating and maintenance cost, excluding energy cost, they amount to 15 million the first year and will increase the rate of 3% each year. Okay, so O&M cost. Yes, here I will write O&M cost is $15 million in first year, increasing by 3% every year per annum. So this is a geometric series. Okay, so we will come to this. So that is 15 million. If the city plans to sell the water for 950 per acre foot, an acre foot is 32581 gallons, enough water for 4 people per year. Can it recover the cost? So here 950 dollar is the selling price. Okay, so sales revenue. Okay, sales revenue will be $950, right? Multiplied by, or see, $950 per 325851. Okay, so 325851 gallons. Okay, so this is gallons multiplied by total annual production. What is the total annual production? Here we can have 18250 million gallons. So 18250 million gallons. So this annual production which we calculated, that I am using here. So this is my revenue. Okay, so how to get the revenue? So gallons will get cancelled, and then I divide these two and then multiply with 950. So let us see, or I'll just do this. 950 multiplied by 18250 divided by 325851. So I'm getting 53.206. I will just ignore that. 53.2. So I'll make it 53.2 million dollars. Okay, so this is my sales revenue every year. So now I got the sales also. Okay, so this data we use, this data, everything we used. Can it recover the capital cost and all other operating cost? Okay, so now the question is, can it recover the cost? So that means what, we need to calculate the present worth of the project or annual equivalent cost of the project. So then we will come to know. So let us do that. So assume the city's interest rate for the project is, so interest rate I is 6%. So let us try to solve this now. So how do we solve it? First, let me make a cash flow diagram for your understanding. So the project life is 20 years, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 years. Okay, so this is the project life. Now, okay, let me look at this one. Revenue. Revenue is 53.2 million. So I'm getting this revenue every year. Okay, so like this, so on, up to the last 20 years. So this is one particular stream. Okay, so this is revenue equal to 53.2 million dollar per year. So this is a equal payments I'm getting up to 20 years, and initial investment cost is 300 million dollars. Okay, so $300 million is the initial investment cost. And what is the salvage value? So here salvage value is 20 million. Okay, so here also I can show salvage value is 20 million, 20 M. So this salvage value also I can find the present for that. Okay, next, what else is there? So there is a savings. Okay, so savings of 20 million every year is there. So here, if I add savings of 20 million, just the same thing, revenue and saving both will be added. So here, plus $20 million per year plus. So this is savings and revenue. So here this will be 53.2 plus 20, that means 73.2. $73.2 million every year for the next 20 years. Okay, did we miss anything? So here O&M cost is there. So this is important. O&M cost 15 million in the first year and increasing by 3% every year. Okay, so first year the cost is 15 million. Second year it will be 15, 3% more, and so on. So this will be like a geometric progression It's not like a straight line, and it will be having a up to 20 years, it will be having some cost like this. Okay, so this is 15 million. A1 equal to 15 million, that is first annual payment is 15 million, and then gradient percentage is 3%. Gradually it will increase like this. Okay. So this is the complete cash flow diagram. So we covered everything. Okay, so savings we covered, and O&M cost, revenue we covered, so initial cost and salvage value we covered. So now based on this diagram, we need to calculate the present worth. So let me take a another sheet of paper. Now how do we calculate the present worth? Okay, so present worth at 6%, right? So first thing, you take this initial investment, so minus 300 million, that is there already. So I'm doing everything in $1 million, in millions of dollars. So minus 300 will be there. Next, let us take the salvage value, 20 million. Okay, so salvage value will be positive. Okay, so plus 20, and here I want P given F, future value, and the interest rate is 6%, and number of years is 20. Okay, so this quantity 20 million is now transferred to the present worth. Okay, so this term we will take care of that. Next, I have equal payments of 73.2 million for 1 to 20 years. Okay, so that also I want the present value given the annual payment. Okay, so I think here I have to give that multiplication, 73.2. So 73.2 multiplied by this one. So equal annual payment is 73.2. What is the present worth? Again, 6% I have to use for 20 years. So I have taken care of this one. Now coming to the gradient. Okay. So for the gradient, what is the formula? Because I don't have this kind of sheet for the gradient. So I'll just go by the formula. Okay. So here, what is the first payment? First payment is A1, okay, $15 million. The first payment, here the formula is something like this. Let me show you. So here there is this online resource. I found this geometric gradient series factors. How to calculate the factors? And if I go down, so there is a derivation, and finally the formula is here. Okay. So this is the formula, and here you can also see the diagram like this: a1 a1 into 1 plus g, a1 into 1 plus g square, and so on like this. Right? So let me open this formula in a new tab. Okay, so I'll just so this is the formula. So A1, 1 minus 1 plus g by 1 plus I to the power of n divided by 1. So let me replicate that formula here. Okay. So 15 million already I multiplied. So 1 minus 1 plus g. Okay. So that means 1.03. Okay. So divided by 1.06 to the power of 20. And this whole divided by 0.6 minus 0.3. 03. 0.06 minus 6% minus 3%, like this. Looks little bit difficult, but it is nothing. It's not difficult at all. In fact, if you look at the textbook formula also, the same formula is there here. So you can see this formula sheet given everywhere, so find last one I'm saying, geometrical series present worth analysis. So here if you look at the last formula, so find P given A1 G I and N. So this is the formula. So this exact formula is what I am using. So 1 plus g to the power of n, 1 plus I to the power of minus n. So that is same thing here. Okay. So now let us calculate. Okay. Did we cover everything? So I covered the savings and revenue, the 73.2, this one I covered. Initial investment, salvage value I covered, and then the cost also I covered. So let us calculate the present worth now. So let's focus on this now. So minus 300. By the way, this is the cost, so here it should be minus sign, be careful. Okay, so now plus 20, and one factor will come here. Okay, that is this factor, plus 73.2, and another factor will come here, minus 15, and then here I'll get one more factor, which is a calculation. First I will do this calculation. Okay, so how do I do that calculation? Quickly have a look at my calculator now. So now I need to calculate this amount. So I think I need a scientific calculator. So I just turn it like this. So first let us take this quantity, 1.03 by 1.06. So 1.03 divided by 1.06, and I got that value. To that x power y, I give exponent of 20. This whole thing should be given a minus sign, and to that I will add 1. So this is the numerator. And in the denominator, if you notice, it is 0.06 minus 0.03, that is 0.03 only. So I simply go for divided by 0.03. So I'm getting this quantity 14.56. Okay, so that is the quantity, 14.56. Now, what about this one? So here I already shown here P by F 6% and 20. So I go for that particular sheet, P by F sheet. So I want to check for 6%. So this column and 20th year. Okay, so 20th year, 6%. So this 0.3769. No, sorry, this is 5%. The next one, this is 6%, 0.3118. So this is P by F. Similarly, this is also positive, that is savings and revenue. For this is a equal payment, so I need to go for P by A sheet. Okay, so in the P by A sheet, again I refer to 6% and I refer to 20th year. So I think this is the value, 11.47. I will take it round off. So now let me calculate this next step. So this remains minus 300 plus. So 20 multiplied by 0.3118. So 6.236 plus 73.2 multiplied by 11.47. So that is 839.6. Okay. Then minus, okay, 15 into 14.56. So that is 218.4. So now I got this. So again, I do this calculation. So 300 with a minus sign plus 6.236 plus 839.6 minus 218.4. So I'm getting $327.4 million as the present worth, okay, at n equal to 0 first year. Okay, that is what is the present worth of this project. So since this present worth is positive, that means we need to go for this project. We need to go for this desalination plant. So that is the final justification. So question here is, can it recover the capital cost and all other operating cost? Answer is yes, it can recover. And we are calculating the present worth. We can also calculate the what is that? We can calculate the annual equivalent. Okay, so how do we get the annual equivalent? Simply, you take the 327.4 million and multiply it with, find a given P for 6% over 20 years. Okay, so like this. So if I can spread this present worth across 20 years, so I'll get like this, 327.4. Now this quantity already we have calculated here, right? P by A is the inverse of A by P. So this 11.47 we already calculated, right? So that instead of multiplying, now I can simply divide 11.47. So what I'll get? So this quantity divided by 11.47. So I'm getting $28.54 million. Okay, so per year. So that means, so your annual equivalence value, so the annual equivalent worth of your project is, so almost you are saving $28.5 million every year. So that is why this is a good project and one needs to go. So I hope you got the answer. So just once again have a look at this question, and it's in a way it is easy, but in a way it is slightly complicated. So I hope you learned something from this video. Thank you.